Okay, so last section we did long division with polynomials. Now I'm going to teach you a little shortcut called synthetic division. Okay, so it's pretty slick how it works, but the problem is it only works if the divisor is linear. So that means if it's something like 3x plus 4 or something like that. So only if it's like a linear line, first degree polynomial. Okay, so how you do this is you only write in the coefficients and constants. You fill in any skips with a 0, kind of like we did in the last one. You divide by the 0, not the factor. And you're going to see just a second what I mean with that. Drop the leading coefficient, multiply, add, and repeat. Okay, so this time, let's actually do it. And I think all this will make a little bit more sense. First, let's figure out what is the 0 of this. So this is what this section right here means. So what is the 0? That literally means what it sounds like. You set x minus 2 equal to 0. And solve it. So your 0 for this one is positive 2. So that's what we're going to be dividing by. Okay, so now it's kind of cool. You make an upside down long division bar. Okay, and now we're going to put this number right here into this spot. So that's going to be our 2. And now up in this first row, we put the leading coefficients. So what do I mean by leading coefficients? I mean these numbers in front of the x's and the constant. So, and space them out a little bit. So you're going to have 1, -4, 6, and -4. Okay? All right. First thing you do is drop the first term straight down. So we have a 1. Okay? Now, you multiply the 2 times that number, 1, and whatever you get, you write it in this spot right here. So that's going to give you a 2. And then you add going straight down. So you're adding. Okay, so -4 plus 2 gives you -2. Now multiply again. This 2 out front, your 0, times -2 would give you -4. Add going down vertically, 6 plus -4 would give you 2. Multiply the 0 by that number, so 2 times 2 would give you 4. Add going down, you get 0. Okay, so this last piece, this is your remainder, which this one has a remainder of 0. But what do you do with those other numbers? 1, -2, and 2. Let me show you. It's actually really kind of cool. You do x squared minus 2x plus 2. So those numbers end up being your coefficients for your answer. Kind of cool. Way faster than long division, I think. I think it gets even faster once you know what you're doing. That was kind of a slow explanation because I just wanted to make sure you got it. Okay, so let's do another one. So make sure, do we have any like skips where we're missing a piece of the polynomial? And I don't believe so, so let's just get after it. So I've got 6, -8, -2. What is the 0? Well, x minus 1 equals 0, so the 0 would be 1. Okay, I feel like that's going to be an easy one. Okay, first thing, remember, drop down the first term and you get a 6. Multiply your 0 times that number, so that would be 6 again. Add vertically, so you would get -2. Multiply it by your 0, and you get -2. Add vertically, and you get -4. Okay, so this one has a remainder of -4. So let me put it in polynomial form. So it would be 6 x minus 2. And then what do you do with your remainder? Well, just like we were doing on the last, the long division, you're going to do minus 4 over x minus 2, your divisor up here, right? And that's it. Way faster than long division. Okay. Now let's do it again. This one, it wasn't quite as nice as me. Can you do it with a fraction? You have some like this. So I just want to make sure you know you can do the same thing. Let's set up the easy part first, then we'll talk about where the fraction comes into play. So we don't have any skips. So 3, 22, 25, and 3. Now this is where the fraction comes into play, your 0. 3p plus 1 equals 0. You would minus 1, 3p equals negative 1, so p equals negative 1/3. And I gave you a negative fraction. That was so nice of me. Sorry, didn't mean to do that, but it's good for you. You need it. So negative 1/3, because you do have one like this on the homework. Okay, let's get after it. So drop your first term down, 3. Negative 1/3 times 3, and if you need a calculator because they get gross, use it, but it would give you negative 1. Add vertically, so you have 21. Okay, negative 1/3 times 21, that would be negative 7. Okay, go ahead and add, going straight down, 25 plus negative 7 would give you 18. Multiply again, negative 1/3 times 18 is what? Negative 6. 3 plus negative 6 is negative 3. So that wasn't too bad. So now let's put it together. We're going to have 3, we're talking about p's on this one, so it would be 3p squared plus 21p plus 18. Then you still have that remainder, so minus 3 over 3p plus 1. Okay. One more of these. So actually this isn't a fraction one, but this one is a little bit different than the other ones. Do you notice anything? We are missing a term. So we don't have our constant term that should be right here. So we're gonna have to make sure we put a 0 in for the skip, because it'll mess everything up if you don't. So I have 1, negative 5, negative 6, and 0. And then what is my 0 that goes on the outside? This equal to 0 would give you 6. Okay, so drop your first term, 1, multiply, so times 1, 6 times 1 is 6. Add, you get 1, multiply 6, 0, multiply 0, 0. Okay, so this one's kind of cool. So that's your remainder always, right? So this would be, you could write it as x squared plus x plus 0, right? Because that 0 still needs a place. Or the kind of the better way to write it, honestly, would just be x squared plus x. I just realized, pretend we're talking about x's in this problem. My bad. If you want to change it to m's, you can. Okay. So just for fun, I want to show you just to make sure that you understand that this works. So I'm going to multiply these out. If I multiply, just to check my work, this is something you could do. Maybe you were struggling, you don't know if you had the right answer and you were on a test or a quiz. You wanted to make sure. We can say x minus 6, which is what our divisor is, times whatever our quotient is, the answer, x squared plus x. Let's just FOIL it out really fast to see. So that would be x cubed plus x squared times negative 6x squared minus 6x. So combine your like terms in the middle. We have x cubed minus 5x squared minus 6x. Is that our original problem? I hope so. Yes, it is right here. So we did it. So that is a quick way you could check your work if you wanted to. Alrighty, so now let's talk about the remainder theorem. So this is just a fancy way of saying what is the remainder whenever you divide by something. Okay, they don't really care about the answer that we were giving, they only care about the remainder. Okay, so it's just more synthetic division. You do have one like this on your quiz. It's actually one of the easier ones. They say, given that p of x equals x to the fifth minus 2x cubed minus x squared plus 2, what is p of 3? So this is your 0 that you were going to divide by. Okay, so what's the remainder when you divide all this by 3? So let's build it. Keep in mind we are missing a couple terms, so don't forget that part. This is kind of a long one, that's okay. So I have a 1. We're missing our x to the fourth term, so that'll be a 0. Negative 2, negative 1. I'm missing my x term, so another 0, and then a 2. And then I'm dividing with my 0 being 3. All right, get after it. So drop it, multiply. So 3, add, multiply. 9, add, which would be 7, multiply. 21, add, 20, multiply. 60, these are getting kind of gross. Add, 60, multiply. 180, add, 182. So this means this is actually our answer, the 182. So you would write the p of 3 equals 182. So that means the remainder when you divide by 3 is 182. Okay, there's more on the next page. Yay! So same thing. Set it up. I don't think this one's missing any terms. That's nice. So 1, 4, negative 8, negative 6. And I'm going to go a little bit quicker because I'm trying to save some time. If you need to pause it and go back, you can. Drop it, multiply. Add, multiply. Add, multiply. Add. There you go. So your p of negative 2 equals 18. One more. So 1, negative 7, 15, negative 9. We've got 3. Let's go. Drop it, multiply, add, multiply, add, multiply, 0, add. So probability, or not probability, so p of 3 equals 0. Okay. Now use synthetic division and the given factor to completely factor each polynomial function. So they're telling you that this right here is a factor of this, but this is another way to factor this long cubic. Okay, so first thing we need to do is we need to divide them. So would you like to do long division or synthetic division? Say synthetic, because that's what we're doing. So set it up. We've got 1, negative 4, negative 9, 36. What is our 0 we're dividing by? Be negative 3. Let's go. 1, negative 3, add it, multiply, add it, multiply, add it. That worked out well. At least there was no remainder, because we wouldn't have been able to do it because it wouldn't have been a factor, right? In order for it to be a factor, it has to divide evenly into there, so it makes sense. So I can rewrite this as x squared minus 7x plus 12, right? And if I wanted to be fancy, I could say, all right, this is actually that times x plus 3, right? Okay, now I just need to keep factoring it. So let's try the trinomial thing. Hopefully it works. What multiplies to be 12 and adds to be negative 7? It looks like -4, -3. Can I use the shortcut? Yes, I can. So I've got x minus 4 times x minus 3 times x plus 3. Looks like that is in factored form. So kind of cool, right? Alrighty, last one, use synthetic division to determine whether each binomial is a factor. So what you do is you just divide them and see if they have a remainder. So let's set it up. 3, 10, -1, -12. And what is my 0? Here's what we're dividing by on this one is x minus 4. So what would the 0 be? +4. All right. So get after it. These numbers get kind of gross. That's okay. What would that be? 88. Gross. Use a calculator. 87. I'm going to cheat because I already have it worked out right in front of me. That ends up being 348. Add it, and you get 336. So is that a factor? Absolutely not. Big fat no. And why is that? Because there is a remainder that is not 0, right? Big fat no. Same thing, we're dividing that same polynomial. So the 3, 10, -1, -12. I'm going to use that again. This time I'm dividing by x minus 1. So what would that 0 be? 1. So get after it. Drop it. 3, 13, 13, 12, 12, 0. So is this one a factor? Big fat yes, because the remainder is 0. All right, that is it for synthetic division. I hope you enjoyed it. It's a lot of fun. Thanks for watching. Have a great rest of your day.